Hello guys, welcome to the video. In this one I want to show you how to make visual feedback on the UI when you cannot build a tower. And also we can use same feedback when enemy enters the castle. A really nice effect, really subtle one. So what we need to do now is go to UI animator and make a method here so we can use it later on any UI element. What we need to do here is to make a header. Let's name it as UI feedback. Let's name it as shake effect, like so. Then we need serialize field, private float, feedback magnitude, or maybe shake magnitude. What you like more, use that. Depends on what you like more. I'm gonna use shake magnitude, I guess. Now let's do serialize field, private float, shake duration. And that's it for now. Then let's do enumerator. We need a private shake coroutine, and over here we need rect transform, and that's it. We're not gonna pass any other variables because we're gonna use variables from UI animator here. Okay. Now we need float time equals to 0, and also we want to have vector3 original position. Let's make it equals to rect transform anchored position. Nice. Now, while time is less than shake duration, we're gonna get float x offset, and it's gonna be equals to random range between minus shake magnitude and plus shake magnitude. Same goes for y offset, equals to random range with the shake magnitude. And then we can take rect transform and change its position. And because we're going to have random values and we're going to do it each frame, it's going to look like a shake effect. So we're going to do equals to original position plus new vector3 x offset y offset. And for the z we can use 0. Okay, then let's do time plus equals time dot delta time, and yield return null. And then we're gonna do rect transform anchored position equals to original position. Perfect. So we have a coroutine. Now we need a method that we can use to start this coroutine. Let's do public void shake, and let's just pass transform to shake, and then inside we're gonna do rect transform equals to get component from a transform to shake, like that. Then we're gonna do start coroutine of a shake coroutine rect transform. I'm not explaining much because it's very similar to what we did over here. It's basically the same. So let's keep it. Now what we want to shake is currency UI and health points UI. Both of those are available within in-game UI, because over here we have currency text and we have health points text, and by using those we can do dot transform dot parent. So this is probably the easiest access to those two UI elements. And what I want to do is to make method that would say something like shake currency UI, shake health UI. But to do that we need to get access to UI animator from in-game UI. And getting direction access, I guess, is possible. We could do that, but it is very possible that we will need UI animator from another UI element in the future. So let's just go to UI over here. Let's take UI anim and let's make it as public, and then let's give it getter and private setter. So now it is available from anywhere. We can simply go to any UI element and just do UI.UI anim. Nice. We're also gonna need in-game UI in a couple of minutes. So while we are here, let's do public get private set. All right, very nice. Now how it's going to work? On in-game UI, we're gonna make a method public void shake currency UI, and inside we're gonna do UI anim shake, and we're gonna pass currency text transform parent. That's it, really. Maybe let's write it like so. And now let's go ahead and make use of this method. And we're going to shake currency UI when we try to build a tower and it's not successful. That we do on a build button. So let's go to UI build button. And over here we need to get access to UI. So private UI. In the wake we do UI equals to get component in parent UI. Then over here, when we try to build tower and it's not successful and we return from a method, we can do UI, in-game UI, shake currency UI. And that's it. Now let's go ahead and see how it works. It's going to be pretty simple to do. The only thing we need to change is we need to go to game manager. And over here, we need to change currency to 1. So we are sure we don't have enough money to build a tower. Now let's go to play mode. And over here, we need to change shake duration and magnitude. And for starters, let's try 0.5. And as a magnitude, we're going to have 5. Now let's select a tile and let's try to build a tower. And it works. I love how it works. It looks very cool. I would probably want to adjust values a little bit. Although this looks really nice. Well, we know how it looks, how it feels. Let's keep it at this and let's try to add a couple of more effects. Later on, if you don't like them, just ignore them, but I want to show you how to make them. We're going to add random rotation next. Over here, let's do serialize field, private float, shake, rotation, magnitude. Then inside, we're going to do float random rotation equals to random range minus shake magnitude rotation plus shake rotation magnitude. All right. And I guess before we set rotation, let me show you something. First of all, we're going to rotate element around Z. This will make it behave like so, like this, 2, 2, 2, 2, 2, 2. And as you can see, pivot point is in the top right corner, so it rotates like that. If you want to have different rotation, you can go here, hold shift, choose pivot point, and then rotation gonna work differently. But I want to have top right corner, just like we had before. Okay, now that you know we're gonna do rotation on the Z, let's go to UI animator. And over here, we're gonna do rect transform, local rotation equals to Quaternion, which is a rotation basically, Euler, 0, 0, and random rotation on the Z. And then after this while loop, let's do rect transform, local rotation equals to Quaternion, Euler, vector 3.0. This will have 0, 0, 0, which will mean we basically set it back to default. Okay. Let's save this, let's see how it behaves. Then I want to show you one more effect that we can add. We had 5.25, and for rotation magnitude, let's try 3. Let's go to play mode. Now you click the tile, choose a tower, see how you feel about it. I kind of like it, so I think I'm going to keep it for now. This looks good. Attracts lots of attention, but at the same time does not really bother me. Now let me show you how to add scale change. And we have scale coroutine over here, so I guess we can use it. The only problem is that if we click button a lot, we're gonna increase scale again and again. So it's better to make a variable over here that will define a local, default scale for UI elements. Serialize field, private float, default scale of UI elements. No, that's too long. Default UI scale, like that. And I guess 1.5 is a good value because that's what I have on my currency UI and health UI. Now inside of this coroutine, we want to increase UI element in size, but we don't want to have it available at all times. We want to be able to easily switch it off while we're developing. So I'm gonna do serialize field, private bool, scale, change available. Okay, then over here, if scale change available, then start coroutine of a change scale coroutine. We're gonna pass rect transform here. No, not color, scale. Change scale. Coroutine. We pass in rect transform. Then as a new scale, we want to pass value that is a bit bigger than current scale of the object. So maybe let's do float current scale equals to rect transform local scale.x. Then we can use this over here. Current scale multiply by 1.1f. So it will be 10% bigger. Then as a duration, we want to pass duration that we're using, shake duration, but I want to divide it by 2. So it will grow up faster than the shake effect we have. It's going to become bigger. It's going to shake, then it's going to shrink back. If you want, you can divide it even more. Then over here, after we did everything, if scale change available, I'm going to do start coroutine. Basically, I want to copy this line of code. And as a scale, I'm going to use default scale that we have. Default UI scale. All right. This looks good to me. Let's save this and let's go ahead and see what we have now as a result. You can easily enable or disable this boolean if you don't like the effect, but let's go ahead and try this with the enabled scale change. Gonna click it and this is how it looks, this is how it feels. I like it. Of course, you cannot read text while it's shaking, but that's not the point. The point is to let player know that something is wrong, and I kind of like how it works. So I'm gonna keep it as it is. Again, if you don't like one of these effects, you can just reduce the value, you can disable it, or you can make rotation 0, or you can change shake magnitude and make it 0 as well. All of that is very flexible and it's up to your design, really. Now let's shake thread UI when we lose an HP. That will be super easy. Let's go to game manager. And on the game manager, we do update HP when we're losing something. And this method is called from a castle over here. So once enemy enters the castle, we remove HP and then we update UI. And at the same time, we can do in-game UI. Oh, we don't have the method yet. I forgot to make it. Let's go to in-game UI and let's make public void shake health UI. Gonna be UI anim shake health point text transform parent, like that. And let's go back to game manager, and over here we're gonna do shake health UI. Nice. Now let's see how it looks when lots of enemies are entering the castle, and we're good with this video. I'm gonna take wave manager and I'm gonna give it lots of enemies. 25 basic enemies. Let's go. Nice one. Really nice one. And it tries to grow bigger, but then it goes back to default one. Really cool. Okay, lots of enemies are approaching the castle. Now let's look here. Yeah, it's good. Lets player know that something is wrong. A little bit annoying. This is what I like as well. Because if you don't like it, then don't lose the game, right? All right, this is good. Thank you so much for paying attention, and I'll see you in the next video.